Should maths and science be taught in a cross-curricular way? Firstly, we will discuss what cross-curricular teaching and learning actually is. In 2010, Hayes defined cross-curricular learning as a method of delivering lessons that allows for subjects to be delivered by thematic or project-based work, meaning that different subjects such as maths and science can be delivered in such a way that will allow progression in each subject simultaneously. By using one subject to enhance the skills of another, making links between central themes or related topics of each subject, and creating a learning environment that can cater for both. This was supported by Malik and Malik in 2011, who suggested that by combining subjects into topics or projects, the children would have to use their existing knowledge and understanding to overcome set problems while gaining new skills in the process. Since its initial publication in 1988, the national curriculum has been criticised by those who prefer to adopt a constructivist approach to teaching and learning. Those who promote the cross-curricular approach disagreed with the national curriculum's rigidly subject-structured model and claimed that it made topic and project-based work difficult, if not impossible. The constructivists' views on learning claim that individuals actively construct knowledge from their experiences and through interactions with their environment and others. The structure of the national curriculum seems strange, as over 60 years earlier the Hatter Report, published in 1931, stressed that primary education should be approached in a way of activity and experience rather than to acquire facts to be stored, and explicitly stated that a project or topic approach is preferable to that of dividing the curriculum into separate subjects. A number of concerns have been voiced around the idea of cross-curricular teaching, and research has been undertaken by a number of theorists and practitioners highlighting some of the difficulties it poses to teachers and the negative impact it can have on a child's learning and progression. Many teachers, particularly those teaching Year 2 or 6, come under increasing pressure from senior management to have their children focusing on achieving expected exam or assessment levels. This can result in teachers teaching children to pass a test and present specific skills to attain a specific mark. This then takes precedence over developing the children into independent and inquisitive learners who would want to ask questions and look to seek out their own answers. This pressure and lack of encouragement, as noted by Thomas in 2012, may also influence a teacher's confidence in their own ability to deliver a successful cross-curricular lesson. Planning a cross-curricular lesson needs to be clear and concise. The purpose of the lesson should still be to meet a specific learning objective, but with appropriate support and guidance to give the child the opportunity to travel their own learning path. It should be noted, however, that in 2002, Ofsted recognised that thematic or cross-curricular teaching was a feature in many successful primary schools. The Primary National Strategy, published in 2005, also encouraged schools to give greater effort to link the theory of numeracy and literacy with other subjects. In September 2014, primary teachers were presented with yet another edition of the national curriculum. This time, the most dramatic change was the omittance of levels, leaving the onus of how lessons should be delivered down to individual schools and teachers. This was a huge step away from the original subject-structured approach back in 1988 and a further move to a more malleable curriculum. The introduction of this format can be considered as a great opportunity for teachers to further develop cross-curricular links between more subjects. The curriculum itself also seems to encourage this by specifically stating that children should also apply mathematical knowledge to science and other subjects. The combining of maths and science became a requirement, which seems to suggest that the government's current stance is that cross-curricular teaching undoubtedly serves as a valuable purpose in children's learning. So how can this be achieved, not only in early years, but also in the subsequent key stages? Over 400 years ago, we were told by Galileo that the universe is written in the language of mathematics. That without the understanding of mathematics, we would not be able to understand, develop, and explain how and why things happen as a matter of specific fact. So how can we achieve a successful combination of both maths and science? So do we take a thematic or topic-based approach? Do we need to teach maths with elements of science, or science with elements of maths? Do we first need specific skills and knowledge from one subject for a combination to be successful? Or does this even matter, as long as the specific planned learning, understanding and progression is occurring? In 2011, Barnes conducted studies and observations that, combined with his own experiences, suggested a number of ways cross-curricular teaching and learning can occur. One of these ways lends itself particularly well to demonstrate how the combination of maths and science can be successful. The hierarchical approach. The aim of the hierarchical approach is to increase progress in one subject by using aspects of another. The progression of mathematical knowledge and understanding can be excelled by its inclusion within a science lesson. For example, reinforcing prior learning of measure and data handling can be achieved through scientific experiments. This approach very clearly demonstrates that it is the maths that is being enhanced by its inclusion within a science lesson. In planning for the combination of maths and science, it would be a science lesson being taught with the inclusion and support of maths. The same lesson can be planned for from early years through to upper Key Stage 2 by changing some specific details, yet still combining both subjects. A good example of this could be a science lesson where the children were asked to find out the best growing conditions for a plant. The question, what are the best conditions for plants to grow successfully, can only be answered with some degree of mathematical knowledge of measure and data handling. This lesson can be adapted from simple non-standard measuring in early years by planting 2 or 3 seeds in different conditions and then using Unifix cubes to later measure the varying heights. Prior mathematical knowledge of the concept of measuring will need to have occurred and will now be enhanced through its use in scientific experiment. Using a simple pictograph to display the findings would also need prior learning to have occurred and will again be enhanced by its use in this experiment. The same experiment can be carried out in Key Stage 2 but with more specific methods of measuring, such as measuring in centimetres and millimetres and by using bar charts or line graphs to display the findings. Again, both skills will need to have been acquired previously in a math lesson and will again be enhanced through use within this scientific experiment. The use of technology within maths and science. In science, the use of technology can be used to provide a context for conceptual ideas which cannot be observed firsthand, such as the topic of planets and space. As supported by Meadows in 2004, who also went on to say that it allows children to visualise and put their learning into a real context. Sculstill et al. In 2013 again supported the use of technology when they argued that it is a very useful learning tool as it can encourage children to become active participants in their learning and can also allow the outside world to become a part of the children's learning process. The use of technology to help develop cross-curricular learning at times can be glaringly obvious, but at the same time pose new questions about how and when it should be used. Clearly, a scientific calculator by name alone suggests that technology can be used to help combine maths and science. However, its use within maths alone may be more detrimental than beneficial. For in a maths lesson, children would be learning ways to find answers mentally, whereas in a science lesson, the learning objective would not be to answer the mathematical equation, but to use the answer to said equation to contribute to the scientific investigation. Tools such as data loggers and talking tins have made scientific investigation more appealing and accessible for most children growing up in the digital age. They also give the children who may be less confident in their own investigative skills the opportunity to access learning in different ways. This was supported by Jensen and Peacock in 2012 when they suggested that technology not only allows children to record data electronically but facilitates creativity by allowing them a choice of methods to record and present their data. In my own experience in early years, I have used talking tins with children who had poor writing skills which prevented them expressing or recording their ideas, but who had lots of relevant things to say. They were able to use the tins to instantly record their thoughts and answers and therefore allowed them to stay involved with the learning and more importantly feel valued for their contributions. When technology goes wrong. As amazing and helpful as technology can be, it doesn't always work out the way we had planned. If equipment hasn't been charged properly, learning can be interrupted. If an internet connection fails, learning can be interrupted. If equipment becomes damaged, learning can be interrupted. Sometimes, the time is needed to actually learn how to use some of the equipment. Would this be detrimental to the specific learning objectives of a lesson, or would this need to be taught as a separate specific lesson in itself? There are many pros and cons concerning the use of technology in the classroom, yet in today's ever-changing, fast-paced digital world, there is no getting away from its increasing inclusion within the classroom in order to mirror the technologies of the real world outside of the classroom. We have looked at a number of arguments for and against cross-curricular teaching, each raising valid points. Depending on the learning objective and the resources and time available, amongst other influences, specific approaches would need to be taken for cross-curricular teaching to be successful. The key to firstly deciding whether or not to deliver a cross-curricular lesson and then successfully carrying out the lesson lies within the precise, well thought out planning which needs to take into account everything we have discussed here today.